Hey,
Yeah, I think we can just continue.
is my internet still bad? Hello?
Yeah, we can hear you.
Oh, hi,
Okay, okay,
Miles.
okay, cool. Let me
You
share
know
my
what? Maybe sometimes going to audio only and stopping the video helps with the network trouble.
Yeah, think.
Oh, you're still muted, Miles.
Yeah, I think Miles should just
I
project and
accidentally
we
got
all turn off the
disconnected and
videos.
now I don't hear anything.
Uh, do you hear us testing 1, 2, 3?
I do now, yeah.
Okay,
Yeah.
you
But
muted yourself for a second.
I actually got completely disconnected for some reason. You know
Oh,
what's weird? It shows my internet connection as being great, but inside of Zoom it says it's unstable. So that's kind of strange. Um, okay. I did find that image. I can share it with you guys. Let me share my screen. Okay. And this was that image. Oops. I don't know if you can see this, but when I saw the number 4 in the book, it reminded me of um, this old comic. So I don't know if you guys have ever seen this before.
no, but it's funny.
Yeah. So let me see. Did I close I might actually have closed. I think I closed, unfortunately, the thing. Let me see if I can find this. Uh, yeah. So again, I have to use this window manager because my other one doesn't let me screen share in Zoom. So I'm a little bit of a fish out of water here. So coming back up here, that 4 was relevant to this. And I'm wondering if the author was inspired by that comic. You guys can see my screen, right?
Yeah.
Yeah.
Okay, cool. Come down here. Okay, so we had some hash optimizations in here. And one of them they mentioned, I think this is Ruby 2.0. It actually just stores the entries directly in the structure up to a certain point. And here he shows 6 items. Okay, so this will get thrown away if you insert one more record. It'll bump it up to key 7, and that will then switch over to like a normal hash table. Or the previous implementation where we actually have bins and stuff. And it just does this because it's faster for it to just check one by one by one directly instead of actually hashing so it's still calling the equal method, but it's not calling the hash method. And it doesn't have to call the hash method because there is no bin to jump to. So that actually makes sense. And I don't know if you guys have ever done like looked at query planner or query analysis like in a database, but sometimes it sometimes surprises me. There'll be an index on the data and the database will just choose not to bother using the index. And it just chooses, it would rather just look at all the items one by one. Like there might be 50 items and it would rather just look at the 50 items one by one rather than use the index to jump straight to it. So it's kind of interesting how this is actually an optimization to completely skip the structure.
Yeah, now I'm wondering about how in a database, how what the cutoff is. Because here
Yeah, I don't
apparently
know.
it's 6
Yeah, here
entries.
it's 6. Yeah, in a database, I don't know where it is, but I do want to say it's bigger than 6. And I don't know exactly why, but it probably also varies by database and other factors. Oh, here he shows calling the equal method on everything. Uh, okay.
Well,
And
maybe
here
in a
we are at the
database,
end.
if it stores the items in order in a database, then that would be a reason. because then it would
If it does
binary
what?
search.
Sorry, I don't know if my audio is cutting out. I couldn't hear you, Nelson.
Oh, if the database stores the items in order in the
Mhm.
table,
Yeah,
then it would use binary search, and you could get you could fit a lot bigger array, or you could store more items in there before it becomes slow.
that could be. Yeah. Well, I guess they're like kind of the uh, it's like its own index at that point. I know Postgres doesn't work that way, but I think MySQL and a lot of other databases do, which I always found weird. I think Postgres does not store the data in order by primary key, which doesn't make sense to me. I don't know why, but um, yeah. But that brings us to the end. He might mention method lookup again in here. I can't remember. Uh, yeah. So this was really a deep dive in hash tables because hash tables are so important to Ruby's internals and are common in Ruby code. I guess that's that. I'll check my notes if I had any. Um, yeah, I don't have any additional notes that we didn't already. We already talked about everything else I took notes on.
Yeah, so I have a question.
Mhm.
Yeah. So all this time, for every chapter we've been looking at, like you guys have been mentioning that some of these things, the things that we look at in this book, there's a possibility that some of them have changed, like they've made changes throughout the way. And then I also posted like one of these videos to Reddit, and someone mentioned that possibility as well, that the book is outdated, so you expect some of the things to be different. I don't know if you guys had researched about some of those ways in which the hash table implementation maybe could have changed or something along the lines.
Well, there was the one I mentioned, which is that I do know I can get the values back out in order that they went in. And Nelson mentioned that was in the previous book you guys read. I don't see a mechanism for accomplishing that in this
Yeah.
structure. So I don't know if that's one of the things that was added after this book was written or not, but that has to be here somehow, and I don't see it.
Yeah, the so in previous chapters, when we've done like the interactive code session or whatever,
Yeah.
we've pasted the code and we're able to see like, oh, yeah, this is different than what the book shows. So some things are a lot more obvious that something has changed. But this is like this would require a lot more research and going into the actual source code for the hash functionality or how it's implemented.
Okay. So yeah, I don't know if Nelson, you have any questions for Miles, because I think we've reached the end of the chapter.
Yeah, we're at the end.
Yeah.
Yeah, I mean, so the only thing that I can think of is like, okay, arrays are pretty uh, simple. Um, that might be the reason uh, that under the hood, the hashes are just a collection of arrays, right? Like
Yeah.
it's
Yeah, I
just
think
for
it's just
speed.
yeah, it's real fast to look up an entry in an array by index, and I think that's why it's like that. I mean, you could do it other ways too. It's just they would be slower. Um, here it does mention this is one of those things where here it says hash tables will always be fast and will automatically expand as necessary. Like Ruby arrays do automatically expand as necessary. So again, it's kind of like it just reminds me of what I said at the very beginning of this session was some of these things are kind of implementation dependent because in C an array doesn't automatically expand, but in Ruby they certainly do. Um,
Yeah, and that really 100% has changed, I think, because well, at least, well, sorry, not hashes specifically, but like integers, because they used to be fixed num, and
Yeah.
when you overflowed the fixed num, it would change to big integer,
Hmm.
but now it's just integer. Everything is just an integer.
Yeah. Yeah, I don't know when that changed. Maybe Ruby 3, but I do remember fixed num and it's not there anymore. Some things I don't remember if it's big decimal or big integer. It might be big decimal. I think big decimal has been moved out of the standard Ruby library and into its own gem. So there's like that just reminded me of that change. Um,
You know, over time, we just get a whole lot more memory, and memory becomes cheaper. So it might have been a memory consideration at first, where they were
maybe.
like, okay, yeah, we must start with very small integers that'll save some memory. And now it's like, well, integers are bigger by default, but we don't have to pay the computation cost of making them bigger all the time, just because they
Yeah.
start out bigger.
Yeah.
Um, yeah, I mean, I think that's a wrap for this chapter.
Yeah. Cool. So who does next week? I forgot. Is it you, Nelson? Are we doing round robin?
I
Oh,
think it's
it's me.
Newton. Yeah.
Oh, it's Newton. Okay. Okay.
Yeah, my turn came back pretty fast. I thought it would take a longer time. Anyway, yeah, so I think we'll be meeting next week. Yeah,
It's a very small array.
yeah,
It is, yeah.
yeah.
Too
Okay.
small to index.
You guys have a great week.